Hey there, science fans! Did you know there's a sorting algorithm that works like a well-organized bucket brigade? It's called bucket sort, and it's all about dividing and conquering. Just like firefighters passing buckets of water, bucket sort efficiently sorts items by first distributing them into different buckets. This makes sorting faster and easier, especially when you're dealing with a lot of data. In this adventure, we'll explore the ins and outs of bucket sort, understand its strengths, and see how it's used in the real world. So buckle up, because it's going to be a wild ride through the world of algorithms. Imagine you're a teacher trying to organize your students by height for a class photo. Bucket sort is like having separate lines for different height ranges. You wouldn't compare every student's height to each other, right? That's the idea behind bucket sort. You divide the data, like student heights, into different buckets, or height ranges. Then, you sort the items within each bucket. Finally, you combine the sorted buckets to get the final sorted result. Now, why is bucket sort so special? Well, it can be much faster than other sorting algorithms, especially when the data is distributed somewhat evenly. Think of algorithms like quicksort and merge sort. They're like comparing every student's height to every other student's height. Bucket sort takes a shortcut. It divides the data first, making the sorting process much quicker. It's like having those separate lines for different heights. You already have a head start. Section 4. Bucket. Sort in action. Sorting floats made easy. Let's see bucket sort in action with an example. Imagine we have a list of floating point numbers. 0.25, 0.89, 0.12, 0.45, 0.67, 0.91. Our goal is to sort them from lowest to highest. First, we create buckets representing ranges 0.0 to 0.3, 0.3 to 0.6, 0.6 to 0.9, and 0.9 to 1.0. We place each number into its corresponding bucket. Then, we sort each bucket. Finally, we combine the buckets to get the sorted list: 0.12, 0.25, 0.45, 0.67, 0.89, 0.91. Section 5. Real-world wonders, bucket sort's everyday uses. Bucket sort is like a handy toolbox used in many areas. One common use is sorting floating point numbers, just like our example. It's also used in Radix sort algorithms, which sort numbers digit by digit. Bucket sort also shines in graphics, helping to sort objects by their color or position. Even in the world of artificial intelligence and machine learning, bucket sort helps pre-process data, making it easier for machines to learn patterns. Section 6. Advantages of bucket sort playing with a full deck. Bucket sort has some neat advantages. First, it can be incredibly fast, especially when the data is distributed fairly evenly across the buckets. It's like having all the ingredients for a cake already measured out. Baking becomes a breeze. Second, it's relatively simple to understand and implement. You don't need a complicated degree in computer science to get it. Section 7. Disadvantages of bucket sort when buckets overflow. However, bucket sort isn't always the best tool for the job. Its performance depends on the data distribution. If most of the data ends up in one or two buckets, it's like having too many cooks in the kitchen. Things can get messy. In these cases, bucket sort can be slower than other algorithms. Also, if you don't know the range of your data beforehand, creating the right buckets can be tricky.